When the steering is turned, a rotary valve integral to the steering input shaft directs fluid to one side or the other of a piston attached to the steering gear. Pressure then increases as required to provide assistance. In a worm and roller steering box, the piston slides in a cylinder in the casing. It has an extension formed on one side, with teeth which engage teeth on the pitman shaft. Pressure applied to either side of the piston produces a force, which is transferred through the teeth to help turn the pitman shaft. In a rack and pinion steering gear, the piston is formed centrally on the steering rack, and the rack housing provides the working cylinder. Seals at each end of the cylinder isolate the power section from the rack and the helical pinion. Seals in the rotary valve section at the pinion input prevent fluid leakage there. Connecting pipes transfer fluid from the rotary valve housing to one side of the piston or the other to provide assistance which acts directly on the rack. The rotary valve is located between the steering gear input shaft and the pinion gear. It consists of an inner member, which forms part of the input shaft, and a surrounding sleeve member fixed to the pinion gear. Turning the steering wheels makes both members rotate in the steering gear housing, but it is the slight relative rotary displacement of the inner member and the sleeve member which controls and directs the power steering fluid flow. This slight rotary displacement is allowed by a torsion bar, which is connected to the pinion gear at its bottom end and the input shaft at its top end. When the steering wheel is turned, there is resistance from the front wheels at the road surface. This resistance is transmitted through the rack to the pinion gear so that the input shaft twists slightly on the torsion bar. Since the inner member is also attached to the input shaft, this twisting provides a relative rotary displacement of the inner and outer members. It is this displacement that lets fluid flow through the valve to act on the piston at the steering gear. The input shaft can twist through only a small angle before it contacts a stop on the pinion gear. This is needed to provide manual steering when power assistance is not available. With the engine running and the steering in the neutral position, fluid flow is directed into the valve assembly through drilled holes in the outer sleeve. As soon as the steering is turned to the left or right, the slight relative movement occurs between the inner and outer members. In the neutral position, the inner member lets fluid pass equally to both sides of the rack piston and return to the fluid reservoir. Equal pressure is applied to both sides of the rack piston. No power assistance is needed. When the steering is turned, fluid is restricted from making a free return to the reservoir. It is now directed to the side that matches the turning action. At the same time, fluid on the opposite side is directed to the return circuit, back to the reservoir. Slight rotation of the valve gives a small amount of assistance, which becomes progressively greater as the torsion bar flexes and more assistance is needed. The grooves of the inner member are precisely shaped to meter the flow of fluid.